students, welcome to your science class. Students, today we are going to discuss about section 3 and section 4 of our block, which is carbon, occurrence of carbon. And our today's topic would be amorphous allotropes of carbon, and we are going to discuss about uses of forms of carbon. So, before we start, let's do a quick recap of what we learned till now. Yes, in yesterday's class, we learned about, we were basically focusing on carbon on Earth topic. We discussed about the carbon cycle. We tried to find out what are the different occurrence level of carbon. Where do carbon occur? Then we discussed about crystalline and allotropes of carbon. So, in today's class, first we are going to discuss about the carbon allotropes and the amorphous allotropes of carbon. So for this we'll need some resources, which is the mustard oil, the cotton wick, one earthen lamp and steel spoon. So let's proceed further. The keywords for our day is destructive, distillation, combustible. So these are the major words which we will be focusing on. The aim of our class is that we will be able to describe how man-made amorphous allotropes of carbons obtained from uh, natural, so how they are obtained from the natural sources, as well as we are going to talk about and we'll be able to explain the uses of different allotropes of carbons, which are determined by their properties. So the first question of the day is like, what makes allotropes of carbon crystalline? So that's the first question. And when we talk about that, there is a question: is coal a crystalline form of carbon? Why? Now, allotropes of carbon are crystalline. Why? Because their particles are arranged in certain geometrical pattern. And coal is not a crystalline form of carbon because it doesn't have fixed geometrical structure and it can be powdered easily. Now, what are these kind of allotropes called? These allotropes are called as amorphous allotrope. Now, coal is the only natural amorphous allotrope of carbon. So time for the activity. We are going to take the earthen lamp. We are going to take the spoon. We are going to put mustard oil in it. We are going to light the wick and we are going to put the spoon on top of the flame for some time and we are going to observe what happens. So what did you observe in the inner side of the spoon? So inner side of the spoon, there was a black deposit which was found, and this is called as the lamp black or the carbon black. What is this deposit called? So you can call it as a lamp black or carbon black. And what does it feel like? It is powdery in nature. And what is the physical state? The physical state would be it is in solid state. Now, why was the lamp black formed during this process? Right. So, uh, yeah, and what does it contain? It contains unburnt carbon particles. So, why was lamp black formed during the process? See, the lamp black formed because there was an unburnt amount of mustard oil, which was not uh, burnt properly. That is the reason we found the carbon black on top of the spoon. Now, all fuels contain some or the other carbon. Mustard oil also contains some carbon. So the unburnt or the left carbon was deposited on the spoon. You can see in the picture here. What types of allotropes it is? It is an amorphous form of carbon. What are the others amorphous form of carbon? So we can talk about wood charcoal, animal charcoal and coke are the some other amorphous form of carbons, and they are made by using destructive distillation of wood, animal, bones, and coals, respectively. So, what happens in this process? Wood, animal bones, and coal are heated in limited supply of oxygen, and that's how they are obtained. What are their properties? The volatile impurities in this substance. Okay, let's come back here. How are they made? So, what happens is the impurities which is there will vaporize, leaving behind the charcoal or coke, which has a higher percentage of carbon. Now, all these are human made amorphous form of carbon. Now, wood charcoal is combustible and is good absorbent, whereas coke is also combustible and has high calorific value and is a good reducing agent. Now, how does the making of amorphous form of carbon affect its properties? Now, all amorphous form except the lamp black are combustible. So, this is because in the other form, the largest amount of carbon remains unburnt and can be used as fuel. Coming to the next topic, what are the different crystalline and amorphous allotropes of carbons and how they are different from each other? Now, oh, graphite and diamond, so they are crystalline allotropes, and while coke and charcoal and lamp black are amorphous allotrope. So there is a difference. So carbon and diamond are crystalline, whereas coke, charcoal, and lamp black are amorphous. Now they are different because in crystalline allotropes, particles are arranged in a fixed geometrical pattern. So when we say this, we are talking about graphite, we are talking about diamond. Now, in amorphous form, they are not arranged in a fixed geometrical pattern. So here comes the how are they different from each other. So how do the properties of uh, diamonds affect the way it is used? Now diamond is used to make gems because it is lustrous. Now it is used for cutting glass and rocks as well because it is hard. It is also used for making protective windows of spacecraft as it is hard. So this is where the diamond is used. Now how do properties of graphite determine the way it is used? Now, properties graphite is used to make electrodes, cells, and batteries as it is a good conductor of heat and electricity. Now, it is used in pencil lead, right, as it is soft and leaves a mark on the paper. It also used as the lubricant as it is soft and slippery. It is used for coloring agent as it is black. It is used to make cubicles for melting metals as it has a high melting point, and it is used for making artificial diamond as its allotropes of carbon. How do properties of charcoal determine the way it is used? It is used as a fuel as it is combustible. It is also used in purifying water. You can see most of the ROs these days has charcoal filter also in it. It decolorizes sugar and extract Vaseline from the crude oil as it is porous and good absorbent. It is used by artists because it is black in color and leaves a mark on the canvas. So these are the few things it is used. It also acts as a reducing agent, hence it is used to extract metals from their ores. How do the properties of coke determine the way it is used? Now it is a fuel. We all know it is a fuel, and it is because why it is used as a fuel, because it is combustible and has a high calorific value. It is a clean fuel, so it is used I'm sorry, it is clean fuel as it is the purest form of amorphous carbon. It also acts as the reducing agent and it is used to extract metals from their ores. Now, how do the properties of carbon black or lamp black determine the way it is used? Now, since carbon black is powdery and black in color, it is used to line rubber tires and make printer ink. So even the shoe polish is what it is made, and carbon paper. It is used in eye cosmetics as kohl or kajal. So these are the few uses for it. So this brings us to end of today's class. Our question of the day. The question of the day is, it is the purest form of amorphous carbon. So among the four options, you will have to choose the right one. Homework we will do, we'll finish S3 and practical question 7 and 10, 7, 8, 9, 10. Please ignore additional question. You don't need to do additional questions. And just in case, if you have any questions or clarification, you can reach me through the comment section. So thank you for your time and have a wonderful day ahead.